Do you know there is an insect called Chironomid? Chironomid belongs to the order Diptera. Insects usually have 4 wings, but Diptera possesses only 2 wings. Flies also have only 2 wings and classified in the Diptera. To be a little more detailed, Chironomid is an insect that is classified in the Chironomid family of the suborder Nematosura. The origin of the Japanese name, Yuzuri-ka, is that the larva moves like shaking the body, so it is written in kanji as shake mosquito. The larvae of Chironomid live in puddles and shake their body quite often. In Japan, you can find many Chironomid larvae in irrigation channels and drains. If the puddle dries up without rain, the larvae will dry out and die. However, Polypedilum vanderplanki, one of Chironomids that lives in the arid region of Africa, can continue to live in a dry condition. Its body is dried up but still alive in asphyxia state. If you give it water, it will recover within about an hour and resume its activities. I don't know if it was first written in English as sleeping Chironomid or if it was in Japanese Nemuri Yuzurika, but anyway, it sleeps when it gets dry. Cryptobiosis is a characteristic of the sleeping Chironomid that does not die even if it dries and can be revived when given water. Sleeping Chironomids can survive even when about 97% of the water is deprived. Many studies have been conducted in various countries on the mechanism of cryptobiosis. In the case of sleeping Chironomids, it seems that the important point is about 20% of the dry weight is trehalose. Since trehalose has the property of vitrifying at high concentrations, it is thought that if the Chironomid gradually dries, it will vitrify in the body, preventing denaturation of biological components. Since the human body contains approximately 80% of water as other organisms, if it goes out of the spacecraft, both water and gases will be taken away. The larvae of the sleeping Chironomid in the condition of cryptobiosis went to space twice. The first time was left in the spacecraft for a few days, and the second time it was left outside of the spacecraft for a few days. In both experiments, they were added water on the Earth and the dried larvae were revived. This is a great ability. During the development of the NanoSuit method, we thought that the sleeping Chironomid might has high drought resistance. If we put the sleeping Chironomid at the starting state to move after cryptobiosis in the electron microscope, it might be alive. This was the working hypothesis. The result was completely different from our working hypothesis. It crashed completely, rather than being active. Water and gases were taken away and the surface structure was destroyed. However, when it is placed in the electron microscope with NanoSuit treatment, it moves like this movie with a fluffy appearance. When the NanoSuit membrane formed on the surface of the biological samples, the structure can be maintained, but the point to note is to wipe the NanoSuit solution to remove excess solution to observe the fine structure of the samples and to prevent the unexpected event. The point indicated by the arrow is an example of the event caused by too much NanoSuit solution. When the film was formed, The excess NanoSuit solution acted as an adhesive solution, causing the stick together of larvae of the sleeping Chironomid at the edge of the sample stage. Thoroughly wiping the NanoSuit solution before placing it in an electron microscope is the most important point to observe the fine structure and to prevent such adhesion. On the other hand, you can use this advantage of the adhesion. In the upper left picture of this figure, the head is fixed to the edge of the sample stage. Since it does not move because of adhesion, you can easily observe it with high magnification. The figure on the lower left shows the head with a slightly higher magnification. If you observe the place surrounded by a square with higher magnification, you can observe the more fine structure. This image is a high magnification photograph of the sleeping Chironomid observed without applying the NanoSuit solution. The surface structure is deformed completely. You can see that the electric charge is accumulated and it looks whitish overall. The fine structure is hard to see due to the accumulation of electric charges. This image is a high magnification observation of the same place as the previous slide after applying the NanoSuit solution. Can you see that the appearance of the surface structure is completely different? If we investigate them continuously with such observations, it might be useful to elucidate the mystery of cryptobiosis in the sleeping Chironomid. I would like to continue to observe many samples by making full use of the NanoSuit method with you. Please use the NanoSuit solution to observe the appearance of the material which you want to investigate with an electron microscope. You may discover new structures reflecting the living state that you cannot see with conventional methods. The technology of the NanoSuit can form an extremely thin film by applying an aqueous solution consisting of a biocompatible polymer and a solvent to the surface of organisms, tissues, cells, and other observation samples, and suppresses evaporation of water and gases from the organisms. The observation using an electron microscope needs a high vacuum, but it is possible to retain the water and gases of individual organisms, tissues, and cells, and to observe them maintaining their original shape. We would like to work with you to develop the NanoSuit method and apply it to various fields such as biological, health, medical care, beauty, and food researches. Please join us. NanoSuit solution is commercially available from Nissin EM in Japan. For more information, please see the home page at http://nissin-em.co.jp/english/index.html